Visitors to the Space Operations Center of the European Space Agency in Darmstadt, Germany, have the unique opportunity to see a satellite that is a true twin of one already launched. It may not have its solar wings, but the Rosetta engineering model is identical in practically all respects to the probe on its way to rendezvous with a comet. Since leaving Earth in 2004, the spacecraft has travelled over 3 billion kilometers, a third of its journey towards comet 67P Tschurjumow-Gerasimenko. Circling the Sun, it has so far swung by Earth twice and Mars once, each time accelerating to reach its target. Each close encounter with a planet is a major milestone. The spacecraft must respond precisely to instructions, and having a fully functional spacecraft at its disposal allows the mission team to investigate on Earth any issues aboard the actual space probe.
Such
maneuvers are critical for us. We must navigate extremely precisely with a precision in the order of 10 kilometers around the planets to obtain the required gravitational acceleration. Before each maneuver, the flight teams rehearse procedures many times. During these tests, we simulate all the upcoming operations, we rehearse and prepare all our actions. We practice to identify all the eventual problems that could arise, to have a team that can react immediately and efficiently. These planetary flybys, with a third and final one of Earth in November 2009, are exciting events mobilizing everyone's attention. However, they are only steps towards the final goal, and everyone imagines the historic moment in January 2014 when Rosetta reaches its destination.
For the first time we will fly, not just fly by a comet for a few hours, but fly in the vicinity of a comet for more than 1.5 years. So this will allow the scientists to collect data over an entire cycle of a lifetime of a comet, from very far distance to the Sun down to its closest distance.
The mission scientists will, of course, be the most thrilled at the prospect of studying at close quarters an object which probably has not changed since the formation of the solar system 4.5 billion years ago.
By studying comets, we actually have the opportunity to look into the past of the solar system and can then see how the solar system had formed, what material was available from the solar nebula and formed into the solar system.
Rosetta will investigate how the comet loses water and dust as it approaches the Sun. But the mission's greatest challenge will be to deploy a small lander called Philae to analyze the comet's surface composition and to drill into the icy nucleus to collect and analyze samples.
It's not just the water, it's also, we know that there are organics on comets. And so some of the organics that were there in the beginning of the Earth, so when life started, might have come from comets.
Although this culmination of the mission is still 6 years away, the flight dynamics engineers at ESOC are already preparing each phase, with 2 intervening flybys which will provide valuable experience.
We have 2 encounters with asteroids, but the position of the asteroid is not known very accurately. In these cases, we have to go with even optical navigation. We have to take pictures of the asteroids as we approach them to assess accurately where they are.
Science observations are being finalized for the 5th of September next, when Rosetta will be obtaining exceptional close-up views of a small asteroid some 20 kilometers in size called Steins.
We are passing by at about 800 kilometers distance, so a comparison would be like standing in Paris and just barely resolving my house in the middle of Germany in Lindau. So it doesn't sound so impressive when you say 14 meters a pixel, but when you add up with 800 kilometers, it's still, you can't expect to do much better.
And with the probe passing Lutetia, a much larger asteroid, in 2010, Rosetta truly will be making the most of this 10-year historic odyssey.
Y eso es también es uno de los puntos más críticos de nuestra misión. Tenemos que navegar muy precisamente alrededor de los planetas para obtener el efecto gravitatorio deseado. Necesitamos precisiones del orden de 10 kilómetros en la navegación alrededor de los planetas para que nuestra trayectoria sea correcta. Hacemos ejercicios de la simulación, de las operaciones por medio de simulaciones. Hacemos simulaciones en que nos entrenamos en las operaciones que van a ocurrir próximamente para identificar los posibles problemas y para entrenar a los equipos a intervenir siempre de la forma adecuada. We have 2 encounters with asteroids, but the position of the asteroid is not known very accurately. In these cases, we have to go with even optical navigation. We have to take pictures of the asteroids as we approach them to assess accurately where they are.
For the first time, we will fly, not just fly by a comet for a few hours, but fly in the vicinity of a comet for more than 1.5 years. So this will allow the scientists to collect data over an entire cycle of a lifetime of a comet, from very far distance to the Sun down to its closest distance. Fino ad ora le sonde sono passate a distanza di centinaia di chilometri, ci sono state per qualche ora, invece Rosetta potrà seguire la vita di una cometa da quando è lontana dal Sole, quindi poco attiva, fino al momento in cui raggiunge il perielio, cioè il punto più vicino al Sole, e anche oltre. Voliamo a distanze di quasi 700-800 milioni di chilometri dal Sole usando pannelli solari. Nessuna sonda fino ad ora ha fatto una cosa del genere, quasi raddoppieremo il record attuale di distanza dal Sole.
Rosetta ist eine Mission, die ein Rendezvous mit einem Kometen macht, also nicht nur an einem Kometenkern vorbeifliegt, sondern wirklich in Orbit um den Kometenkern geht und von da aus genau analysiert, woraus der Kern besteht. Deshalb ist es wichtig, dass wir verstehen, wie Kometen zusammengesetzt sind, weil sie ermöglichen uns quasi einen Blick in die Vergangenheit, sodass wir wissen, wie Objekte aussahen, als sich unser Sonnensystem gebildet hat, vor etwa 4,6 Milliarden Jahren. Und verstehen wir das, dann wissen wir auch, wie es sich weiterentwickelt hat in das, was wir heute sehen, wie zum Beispiel, wie die Erde jetzt aussieht. Seit der Giotto-Mission wissen wir, dass ein Kometenkern zum größten Teil aus Wasser besteht, aus Wasser und gefrorenen Gasen und vermischt mit Staub. Die genaue Zusammensetzung wissen wir immer noch nicht, weil wir mit Giotto ja nur das Material messen konnten, was den Kern verlassen hat. Die Giotto-Mission war ja ein Vorbeiflug an einem Kometenkern und wir haben gemessen, was in der Kometenatmosphäre ist. Mit Rosetta sind wir nun in der Lage, auch den Kometenkern selbst zu vermessen. Wir werden mit dem Rosetta-Länder auf dem Kometenkern landen und dort Proben nehmen in 20 cm Tiefe und werden genau analysieren können, woraus das Kometenmaterial besteht.
We are passing by at about 800 kilometers distance, so a comparison would be like standing in Paris and just barely resolving my house in the middle of Germany in Landung. So it doesn't sound so impressive when you say 14 meters a pixel, but when you add up with 800 kilometers, it's still, you can't expect to do much better.
The backup procedure for transmitting the OS to you, so assumes an FTP server which is not existing anymore. Okay.
Ja, gut, das ist der Inhalt von dem Ding.
Ja, die Zahl hatte ich teilweise verglichen.
Ja, genau. Das passt auch. Das
Rosetta Sims, Flight Dynamics in the OM Blue.
Flight Dynamics, this is Sims Officer on the OM Blue.
Sims Officer Flight Dynamics.
You can ignore it.
Do we have a backup procedure?
Yeah.
For Rosetta?
to disable the SHM entry as up.
Yeah.
Just check something. Yes. We have moved to LGA. Rosetta Mission, we will just disable the SHM entry. That's only perfection.
Usual.
Where is the only one? Is